Hello everyone and welcome. My name is Eric Coleman with IIST and I will be the moderator for today's webinar, Defect Prevention, the Role of Testers in Improving Process and Reducing Cost of Quality by Dr. Magdi Hanna. We're excited you're able to join us today and set aside an hour to attend this webinar. This webinar is one of a series of free webinars to introduce the topics as well as the presenters of the upcoming PSQT Conference in San Diego, California, August 14th through the 19th at the Sheraton San Diego Hotel and Marina. PSQT is the only conference that focuses only on practical best practices in every aspect of software quality assurance and testing. The ongoing theme of the conference, Practical, Proven, Feasible, keeps the focus on what works. To learn more about this exciting conference, visit psqtconference.com. You may submit your questions at any time by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is being recorded and will be made available for viewing within 48 hours at psqtconference.com. At the end of today's webinar, you will be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you could take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Dr. Magdi Hanna. Dr. Hanna?
Thank you, Eric. Thank you. Thanks to everyone for joining us this morning. I'm pleased to spend the next hour or so with you this morning to share with you what I believe to be, in my opinion, the real role and responsibility of test professionals. To start with, here is kind of the agenda that I am going to try to cover today, and I should be able to. We're just going to have a quick introduction about defect prevention and how quality control is different from quality assurance. Then we're going to talk about 4 different activities, or if you may say tasks or ways of doing our job as testing professionals, by which we really prevent problems from coming into the software to start with. The difference between prevention and detection is kind of fuzzy to some people, because people assume that if we spend a lot of time testing and as a result we're finding a lot of problems and we're putting out releases that do not have as many defects as normally happens, then we are preventing defects from going to the customer. That when you prevent defects from going to the customers, that's too late in the life cycle. When we test to find those defects, this is defect detection. Defect prevention is about preventing defects from getting to the software to start with, which means when we start testing, we should not be finding as many defects as we used to have before. Of course, it depends on how early in the life cycle we can prevent defects. So the goal of defect prevention, in my opinion, is simply to minimize the number of defects found by the test team during testing. Now, of course, when we say the test team here, it all depends. If we are in an agile project and developers are doing a lot of testing, when developers are doing testing and they cannot find as many defects as they used to find, that's a very early defect prevention. When you have a QA team that performs testing, even in an agile project, after the code has been written and tested by developers, and then those testers do not find as many defects as they used to find, that's also a defect prevention, although it's one step later, or it's later than what happens in development, and so on. And if you have a user acceptance testing team and they don't find any as many defects as you normally find. That's also defect prevention. So my goal is to really do it in the right place, which is defects found by the test team should be reduced as much as possible. So my goal is to minimize or to have a major reduction in the number of bug reports written by the development team. So I don't know if I need to, I'm sorry, by the test team, I misspoken. Find as many or reduce the number of defects or number of bug reports written by the test team or QA team. I don't know if I need to explain to you why we need to do defect prevention. It doesn't take a genius to figure out that finding defects and fixing them costs much more money. Now, of course, everyone, the literature is full of evidence. It's full of data there that says, you know, the earlier you can find the defect, the better it is. Well, guess what? Imagine if you don't find defects at all, which means there is no defects to start with. Imagine how much the saving is. So the cost of rework, we already know that. Every manager, every director, every VP, every CIO, they all know the cost of rework. It doesn't matter at what point we do the rework, but as long as developers are going to work to fix problems that were found by someone, and the test team is going to work to retest bug fixes, all right, that's rework. And everyone knows about the cost of rework. I'm not even here to argue that. I'm not even here to tell you that we need to avoid the cost of rework. That's just one tiny piece of the benefits of defect prevention. To me, defect prevention, when you actually do it, it even achieves much more than that. Typically what happens is that the development team write the code, and that's true whether it's an agile project or non-agile project. I'm not really talking about a specific development methodology here. The test team starts testing, and you know, we find problems and we write bug reports. And developers take those bug reports and fix them, and they send us bug fixes. But I'm sure you know what else comes with those bug fixes, right? More defects, more defects. And that is true. No one can deny that. Based on my experience and your experience, we cannot deny that. Most of the developers will agree to this. I think the question is, how many more defects are introduced as a result of fixing a bug or fixing a defect? This is what's questionable, okay? Now, I've seen people in the literature talking about ratio 1 to 4. 1 to 4, meaning that they say every time the development team gets a bug report to fix it, and they fix it, they break the software in 4 other places. And maybe that's why I have 4 question marks. No, just kidding. That's not. Some other people said it's 1 to 2. Some people said 1 to 3. It doesn't matter what the ratio is. What matters is there is a ratio. It is not 1 to 0. Let me tell you that. It is not 1 to 0. No developer I've known that I worked with, including myself, when I actually wrote code and did design, no developer can always consistently get a bug fix and fix it without breaking the software in any other place. I have confirmed this over and over again with developers. And if I have developers with me today in the webinar, and there is a developer out there who is willing to say, yes, I always fix the problems and I never break the software anywhere else. Please share this with me. I will not share your name, but certainly you got yourself a job if you are honest in what you're saying. All right. I have asked this question to developers all the time when I teach developers, when I meet with developers. I've taught courses to developers, and I've asked this same question over and over again. I say, is there anyone here? So I tell them about the ratios 1 to 4, 1 to 3, 1 to 2, and I says, let's forget about everything in the literature. Let's assume it's 1 to 1. And I say, is there anyone here who could possibly, in the average, fix a bug or fix a defect and does not break the software in just one place? And I'm talking about the average here, which means what? Which means the system is telling me that I have a loud microphone level. Sorry if this is coming to your ears, so I'm going to reduce my voice a little bit. So I'm talking average, meaning that you can have a good developer who gets bug reports, he fixes them, does not break the software today, tomorrow, after tomorrow, but then one day he's got a really bad bug report that it takes him a couple of hours to set, and then that's when he breaks the system in 5 or 10 other places. So the average is 1 to 1. All right, let's agree that there is a issue. Let's agree that at the very least, in the average, a development team will be introducing at least one new defect. And one more time, I will repeat, this is the average, meaning that you may actually have one developer who does not introduce too many defects, and you might have one of those other developers that you know and everyone knows, and I know some of my developers, by the way. The moment they started playing with the database and fixing the problems in the database, guess what? You cannot predict what could happen from those developers. So an average is across all bug reports, across all developers. Even if it is 1 to 1, guess what? It's a very serious problem. Because the problem when this happens, of course, some of those newly introduced defects can be found here. But that's only if you have a good, robust regression testing process. But what if not? What if not? What happens to that? It goes out to the customer. Those defects that are unknown defects go to the customer. And nothing irritates our customers more than having the software that worked yesterday or worked last week and it does not work today. And it does not work today because they're newly introduced defects and because we did not catch those. So I think we agree that the problem with defects in software and there's a cycle of detect, fix defects, the problem is much more than the cost of rework. The problem is specifically interruption to the business, unreliable systems that who knows what the system is going to do with people. If that's a mission critical software that actually there are defects there that were unknown. All right, we don't know what those could do. So really that's my concern. My concern is what's here, not in the cost of rework. Not in the cost of rework. All right, let's move further. So now that brings a discussion about the difference between quality assurance and the quality control. We're all testers. Every one of us, I don't want to generalize here because I'm assuming that we have with us today people of different titles. I did not pay attention to the titles of people who are with us today. But as test professionals, we are known that our job that we get paid for is to test software, find defects, report to those defects, and wait for developers to fix them and then come back to retest the bug fix. We all know that. That's what we get paid for. And there are some people out there who just to get paid for that. Maybe more than 80–90% of test professionals. And again, if you have a different opinion, if there is different practice in your team, I would love to hear about that so that I can share that kind of success with everyone else. But I am saying 80 to 90% of people who are in the test profession, they get paid for finding defects, analyzing the defects, reporting those defects, and coming back to retest the bug fixes. If you do something as a test professional, if you're doing something more than that, please share with me. What we're going to do today is to change this slightly. Meaning what? I'm not going to ask you to go back to your project and don't do this. Of course, you will continue to do what you get paid for. You will continue to test and find defects. But you will do things that hopefully over time, you do not write as many defects as you're writing now. That's really my goal. So when you get the defect, when you get the software in your environment, you're trying to test, things are running smoother, much smoother than before. So that's what I consider defect prevention. So to summarize, quality control is what we know as testing. Everything we do in testing is considered quality control. And this is by the definitions of Dr. Edward Deming. Edward Deming, a long time ago, he gave us this wake-up call. He said, we've been wasting time. We've been wasting time finding defects, getting those defects fixed. And he was not talking about software specifically, he was talking in general. Every process has a defect detection component of it that in which we find defects in the product. So one of the keywords here in quality control is products. We find defects in the product, and when we find defects, we go and get them fixed. Every form of testing, as well as inspections and reviews, in my opinion, are considered quality control. Even people think that, and you can imagine how many books out there that kind of think that or dictates that inspections and reviews are quality control. No, they're not, because there is still defect detection process. They find defects. It is true that they find defects early, but they still find defects, and the defects needs to be fixed, and there is a rework cost, and then there is the same cycle. It's just the difference here, if I may go back to this slide, the difference here is that the inspection process is in between here, in this area here. So we find defects here, we send them back to developers to fix them. Same thing. It just, as I said, we find defects earlier. Now, if we really want to practice quality assurance, and I'm sure many of you have the term QA or quality assurance in your title, what I want you to do is to ask yourself, am I really quality assurance professional? Or am I a testing professional? This is very basic stuff, guys. This is very, very basic stuff. Am I really truly a QA professional, not just a test professional? And the difference is this. The difference is simple. The difference is something we've known for life, which is what? Learning from mistakes, learning from defects. How can we do our job in a way such that the defects that used to be found are not there anymore? The problems we've been having are not there anymore. Now, this is not theory. This is not theory. This is practice. I teach you this, every week. In my courses, especially the course on best practices in software test planning and design, and people asking me, says, what is best practices? We've been doing testing for years, for ages, and so why are you coming today with something that you call them best practices? How did you know that they are best practices? And I say they are best practices because they're focusing on defect prevention. This is what we need to do. All right. So everything I'm going to be talking about here is actually explained in much more details in my 3-day course, which is also available online from the International Institute for Software Testing. But you should be able to get enough from this webinar today. So QA happens throughout the process, development and testing. It focuses on the process. Everyone knows that. Everyone knows that. I mean, I'm not telling you anything probably many of you do not already know. When we think QA, we focus on the process. The question now is, which process are we focusing on? It's not the development process. The development process is not our process. It's every process we are involved in, and I'll share with you in a little bit. When you focus on the process, your goal is one thing, is to control that process to prevent problems from getting into the product. So as a result, anytime we look back at any process and try to improve it in a way that prevent defects is considered quality assurance. And that is what I want our test professionals to become. Now, I'm sure many of you would say, that is not what I get paid for. I don't get paid to look at processes and improve them. Well, it's not like what you think. You will continue to do your job that you're getting paid for, but you will do your job in a different way, such that while you are doing it, you're doing it in a way that you are really preventing problems from happening in the next release. So that's, in my opinion, as test professionals, we need to become really QA professionals at heart. We need to practice QA in our test job. Now, how do we do this? Because I've been talking a lot, and I did not about what we need to do. Not yet. I didn't tell you yet how we can do this. Here's my first practice that I've been teaching people almost for the last 18 years now. Now, closing the gap between development and testing with collaboration. Someone says, all right, what gap are you referring to? Well, hopefully when I put this in the slide in front of you, some of you who are working in Agile projects say, oh yeah, that is what we do, because we don't have testing and development in the Agile project. We have an Agile team, and we collaborate a lot. And the assumption is that collaboration is a big thing in Agile. I'm glad you recognize that. The question to you, do you really close the gap? Let's talk about the gap. The gap really is about how developers are thinking and how developers are writing their code and the design versus how the test team is designing their tests and running their tests. The gap here is what is in the code that developers are not testing. Sorry, what is in the code that testing people are not testing? The question you need to ask yourself, am I testing everything in the code that my developers wrote? This is the ultimate collaboration, by the way. This is the only way we can close the gap. In a way, you're asking yourself, what is the level of code coverage in my work? And many testers would not even care about code coverage because it has the word code in it, and they think because it has the word code, it is the responsibility of the developers. Code coverage is the responsibility of the whole team. I don't care if it is Agile or non-Agile. I care about one important thing, code coverage. I know some of you would say, why is it so important? Because I have seen projects failing all the time. And when analyzed, found that the real cause of failure is very low code coverage. Meaning what? Meaning that the test team is only testing 50 to 60% of what's in the code. And there is about 40% of the code in a typical project that's not being tested. I know this might come as a surprise to you, and please share with me any comments, any challenging questions, any different opinion. Share with me in the questions panel. Click on questions and put it. I'm just peeking in now. Got a number of questions there. Um, some of them are not really questions. Let me read this. I know most of our speakers like to defer answering questions till the end. I'll try to answer some of them during, but I'll answer the rest at the end. That question, let me defer that question to the end. Okay, let me wait, because some of these questions really will be answered from the presentations. So, all right. So maybe it's better to wait, and it becomes easy now to answer the questions much quicker at the end. So we understand the code, the gap in between the code and the requirements, between the what developers do and what testers do. This is there, by the way, and this gap is always there. Please, let's not fool ourselves and say we are following agile methodologies, Scrum or otherwise. I must say that yes, some of the agile practices will minimize the gap, but some other agile projects will not, and will not do anything to the gap, and the gap will remain there. In fact, I found many agile projects cause that gap to be much bigger than in a non-agile project. Let me explain why. Remember, in agile projects, we're not supposed to write 100% complete requirements. We write user stories that are probably very brief. Sometimes we elaborate on user stories. We write what we call verification criteria or implementation criteria or whatever. But the truth is, in any agile project, we encourage and we nurture a relationship between developers and the product owners, and between developers and everyone else, to elaborate on the requirement during the development process. So the truth is, developers start their development effort without having a complete understanding of what the requirement is. And that's why we call it an iterative process. It's an iterative process because we do what we know now and we show it, and as we go, we will improve on it. I mean, we can't have it all, right? We can't have it all. In Agile, we say we may not have 100% complete requirement, but we have something to start with. And we follow an iterative process by which we can evolve the requirements and evolve the functionality as it becomes clear and as more questions come. I want to caution you about this iterative process. I hate to sound negative and say I want to caution you against Agile. No. Agile is not a bad practice. Agile is like any other practice. You can do it right, you can do it wrong. Non-Agile traditional is also practice. You can do it right, you can do it wrong. That's why when I teach people about Agile, I said, let's talk about best practices. Whether those best practices exist in Agile and the Scrum or exist somewhere else, it doesn't matter. We need to know what the best practices are, and the practice I'm talking about here, which is about closing the gap, is best practice. If an Agile or non-Agile project does not work on closing the gap, then that is a problem. So we need to work on closing the gap. So Agile projects will say, of course we do. Why? Because we have this our Agile meeting every morning for 10-15 minutes. Well, that is not a form of collaboration. That is a form of coordination, if you will. Again, I'm not against the Agile meetings in the morning. I mean, you got to do those. But what you have to think about is that, are they really achieving the goal we're supposed to achieve? Are they closing the gap? Are these meetings really helping us maximize our code coverage. And the truth, as far as I know, unless you have different experience, my experience suggests that no, those meetings do not increase code coverage, do not help improve code coverage, do not help minimize the gap or reduce the gap or eliminate the gap. No, we talk about coordination, about what we're going to be doing. So what are the kind of things we can do to minimize that gap? Here is again one thing that I've been teaching people. You might have already attended some of my free webinars on scenario-based development and testing. This is very simple. When I put this chart in front of people, every time I put this chart, just out of curiosity, how many of you have seen this chart before from me? I mean, you would have only seen me seen the chart if you have taken my webinars or my courses. All right. Just if you've seen this chart, just to see how many people are returning customers here. Just raise your hand. Click the raise of a hand to show me if you have seen this kind of chart before, which simply describes the process of scenario-based development and testing. Okay, we've got few people here. Okay. No, not few, but roughly 10, 12 out of 70, about 20%. All right. Without making this boring for you, this is very simple. Every time I put this chart, I say to myself, this is common sense. If any project, agile or non-agile, is not doing this, what are they doing then? They're not really doing the right thing. Why? Because I know this sounds a bit arrogant, right? So if no one is doing what I'm talking about, then they're not doing the right thing. Well, let me explain why. All of these things, we're going to take a requirement, any form of requirement, a user story, whatever, high-level requirement, vague requirement, incomplete requirement, ambiguous requirement, like all requirements are. We're not going to even argue that because I have stated it more than once, that all requirements written by anyone, including myself, are incomplete, ambiguous, and has many other problems. So we need to be able to analyze the requirement and ask questions, and most importantly, record the answers to those questions. Okay, and I covered that box by itself in a different webinar called Online Collaborative Requirement Reviews. My purpose here, or my goal here, is that every question that gets asked about a user story or requirement gets documented somehow. Now, I know some people in Agile projects will say, well, we're trying to reduce the amount of documentation. So we do not want to create another document that has the questions and answers. I am not suggesting that you create another document. There is a way to do this, and I don't want to. Collaborative requirement review approach that I teach is simply about putting the requirement online and asking the questions online, and when people ask questions, those questions are recorded as part of the requirement, and you're not recording those. The tool, whatever tool you're using, is recording those, and when someone goes and answers the questions, the answers are also recorded as part of the requirement. So if at any time historically someone goes back to this user story or that requirement to find out what happened, they can see all the questions that were asked. They can even search those questions and answers on certain keywords, and they can say, yeah, Joe asked the question here about 3 weeks ago, and Kathy answered the question this way. Now, the questions and answers become part of the requirements. Once we have that, then the next step is to build scenarios. Absolutely. Build the scenario. So just to make okay, this whole presentation is not about scenario-based development and testing, but let me define scenarios are, and many of you already know that. Don't overload the word with anything. Don't make it complex. Don't complicate issues. Scenarios are, as it says, according to the English dictionary, it says what? It's a situation. It's a condition that could happen. Very simple, one single phrase that describes a scenario. I'm not asking you to follow a different methodology. I'm not asking you to do something that someone is going to say, oh, we're going to add another layer here. It's not another layer. If you're looking at a requirement and or user story and you are not thinking scenarios, I am sorry to say you're not thinking. Because scenarios are what is going to be encountered in the field. Scenarios need to be written from the user's perspective, also from the perspective of people who are going to be performing user acceptance. Scenarios should describe the kind of things that happen in the field, in production, and they should be documented. There is a huge process about how to define scenarios, and I explain this in the course. But of course, some of those scenarios are what we call positive scenarios, some are negative scenarios. How do you sort out scenarios and so on? At the end, you need to validate those scenarios. And scenarios must be validated by everyone involved. But if you're an agile team, then the product owner, the Scrum Master, the developers, the testers, the users, anyone involved should be participating here. The validation of scenarios is very critical, by the way. It's simply saying, have we covered everything that could possibly happen in production? And let me tell you this. We are not supposed to move, or developers are not supposed to move to writing the code and writing the design before those scenarios are finalized. Now, there is, of course, always a chance that a developer is sitting there writing the code, and he or she would think of a scenario or two that were not here. And when that happens, they go back and put the scenario in the place where all the scenarios are. And since this process is going to be an online collaborative process, then everyone else in the team knows about the scenarios that this developers, and the developer is putting the scenario there, kind of saying, I thought about something else here we need to do. So it's still an iterative process, because some people look at this and says, that's a waterfall model. Absolutely not. That is not a waterfall model. That's the most iterative process you can think about. Why? Because I'm giving a chance to developers here as they're writing the code, and giving a chance to the testers as they're writing their test cases and test scripts to come up with more scenarios. The only thing I will say is, if I find that there is much more scenarios coming out of here and coming out of here, but they're not coming out of here, then we have to go back to this process of defining, of analyzing, defining, and validating scenarios, and find out why we are not thinking enough scenarios here. Because, of course, someone might say, so what difference does it make if we can come up with scenarios here or here? In fact, some people would go to the extreme and say, why don't we just eliminate these two boxes then and do what we've been doing? Get the requirements, analyze, ask questions as much as you can, and give it to developers to write the code, and give it to testers to write the test design. And then you're going to find more scenarios. Please don't do that. That's not an effective process. You're not going to be able to master this process in a way that all scenarios gets communicated well. That step right here, validation of scenario, is very critical. Because as part of the validation of scenarios, for example, we decide on what is the expected behavior of a scenario. Sure, we can know, a developer can think about a scenario. Now the big question here is that would a developer really know that this is a new scenario? Maybe not. Does the developer know how the system should handle that scenario? The same way the product owner or the business analyst or the customer wants it to be handled? Or the same way the tester would know how to handle it? Right. So as a result of this process, and I don't think you can challenge me here unless you actually try it. I say this because I have companies who tried it. I have companies who reported major reduction in bug reports, as high as 70% less. I get companies who said, we've been able to reduce the number of open tickets by more than 70%. I get companies who said, when we use the code coverage tools here at the end, after the code has been written and the test cases have been written, we ran the test case through our code coverage. We had levels of code coverage that are 95 and 97%. That's really these two objectives are your goal here. Maximize code coverage, minimize the number of bug reports. This way, when the test team is testing here, they're not finding as many defects. So going back to this slide, we are reducing the flow of bug reports from testing to development. Because really that's the only way I can overcome those unknown problems or unknown defects going to the customer, is by trying to reduce the flow of bug reports from testing to development. And as a result, I am reducing the amount of rework, I am reducing the cost of rework, I am reducing the number of unknown defects going to the customer, and reducing the interruption to the business. Okay, so that's one thing. Here are some forms of collaboration. Basically, if you're writing scenarios, you must share scenarios with developers. Make sure that developers and testers are on the same page. I'd like to hear from anyone with me today. If anyone is willing to say, well, I don't know if it's going to work with us. I see no reason that this would not work in any project. I say, take that chart, share it with other members of your project team, and say, can we do this? Does this make sense? And I'm going to tell you this. Of course, every once in a while, I teach this topic in some of my live courses, and every once in a while, I get someone says, are companies not doing that already? Are companies not doing that already? And I say, not every company. Now, of course, let me emphasize an important thing, because a company could be doing all that, but the only one thing they're not doing is that developers are not waiting for the scenarios to be validated. So in many projects, agile or none, developers are anxious to get their hands on the requirement and write the code. So this process is not about whether you're doing scenarios or not. No. This process is about, are you finalizing your scenarios, or at least 80% finalized, before developers are writing the code. This process is about, are developers writing their design or their code based on scenarios or based on requirements? No one should tell me that it's based on both. No, because we have already taken the requirement, broken it down into 15, 20, 30, or 40 scenarios. There should not be anything in the requirement that's not here. And testers would be focusing on this. All right? Now, when I spoke about sharing scenarios, I meant to say a person here who's writing scenarios or found more scenarios or whatever must go back to the development team and say, I'd like to share this with you. Let me see if we're missing anything. We have to bring those two processes to the same page, no matter what. In fact, we should be able to map every single scenario to a block of code here, and map every single scenario to a bunch of test cases here. And when we do that, by default, those test cases, so if I put my hand on one scenario and it says this scenario, Joe, Mr. Joe developer, where is the code? And Joe says, here is the code. This block and this block of code and this block of code is handling that scenario. Great. And the tester, where are the test cases for that scenario? If we can have a tool, which the tool is there, if you're familiar with the Romana ALM, it's an ALM tool, it does this exactly. You go from the scenario screen, you can see the code modules that were written to cover the scenarios, you can see all the test cases that were written to test the scenarios. So by default, you are really looking at the test cases that are used to test every single block of code. So there is no way to have blocks of codes here or modules of code here that are not being tested. Otherwise, where are they coming from? How did the developer write them? If the developer is writing all their code or his code or her code based on the scenarios, then there shouldn't be anything here that's not being tested. That's really what I'm talking about. There shouldn't be any code written by developers that's not being tested. So sharing scenarios with developers before design and the code has started. What if the developer did not wait for me? What if the developer got their hands on the requirement and started writing the code? Well, guess what? You still have to share your scenarios as a tester professional. You share your scenario as a true QA person. You share your scenarios with developers, because what you're trying to do is to make sure the code as being written by the developer is in line and in sync with your scenarios that you're going to be testing. Of course, the developer might say, oh yeah, we handle this in the code. But then you go beyond that and says, okay, and how is it handled? What's the system behavior? How is the system handling this scenario? Then you start to talking about the expected behavior of each of the scenario. And if you find that there is mismatch between what the code is written and what the tester is doing, then that needs to be fixed right there. We shouldn't be waiting until we test it and we find the problem during testing. Now, I suggest also if your project is doing code or design reviews, absolutely test professionals should be attending those, and the purpose of those meetings should not be to make sure the code is working, to make sure the design is correct. Now, people ask me a lot about, so what's an ideal goal or objective of a code review or design review process? I say it's mainly to find any mismatch between testing and development. Okay, so that's the purpose. So testers there to make sure that whatever scenarios they have, they're testing what the code, how the code was written, and if there is any mismatch that need to be resolved there. If your project is not doing code or design review meetings, then you got to invent something. I suggest that we have a daily or a weekly update meetings, and the purpose of those meetings, those are not status meetings. Those are meetings where we make sure that, again, everyone is on the same page, and they're not the 10, 15, or 20 minutes agile meetings in the morning. No, this is simply saying, you as a developer, you need to tell me what you have done today or yesterday, and this, by the way, after the fact, not before. So if we're holding those daily meetings, they would be at the end of the day. And the purpose of the meeting at the end of the day, for developers to share with the test team and vice versa, what they have done during the day that can affect the other person's work. Okay? So as a developer sitting there working throughout the day, I'm taking notes. I'm taking notes to share in my 15, 20 minutes meeting at the end of the day. I have been suggesting those meetings. They have been implemented in many companies. They work. They work correctly. They work very nicely. And of course, another form of collaboration is to find a good tool that would help you put the requirement there or the user story, collaborate. And there are so many tools in the market about that. Okay? All right. One more practice, and probably we'll start answering questions. Sharing testing responsibility with developers. Okay, what is that? Well, guess what? You cannot possibly, if you actually follow, and this practice, it almost becomes mandatory if you are doing scenario-based development and testing. Why? Because if you follow the process I just explained, you will come up with much more scenarios than what you can ever test. You'll come up with much more scenarios than what you can ever test. So, and I get this complaint a lot from test managers. Say, well, I like the process, But if the process is going to take a requirement, break it down into 60 or 70 scenarios, where are we going to have time to test all those? Well, I say you are not going to test all those. The process was to come up with the scenarios. The process does not dictate that you must test all those scenarios. Oh, really? So what are we going to do with them? Well, during the scenario validation process, we come to this process, which is simply it's a risk analysis process. You list all the scenarios for a given requirement. I just listed 9 here so that I can fit them on one slide. But typically for a given requirement, you're going to have 50 or 60 scenarios. And you start deciding on which scenarios need to be tested. Based on what? Well, very simple. This is a very simple risk model here that uses the impact of failure. All right. If the scenario were to fail in production, what's the impact? How often do we see the scenario? And what is the probability of failure? What is the likelihood of this scenario to fail? And a lot of people say, well, how do I know? How do I assess that a scenario may fail or may not fail? Well, I give you a few hints here. If the scenario you're talking about is not explicitly stated in the requirement, and that's a very important point, because during the scenario validation process, I ask people to tell me or to indicate for each scenario whether that scenario is explicitly stated in the requirement or not. And you should see the spreadsheet that I collect, and if any one of you have taken my 3-day course, you participated in this workshop, and your data is going to be in my spreadsheet, which I'm not going to show it to you now. But the spreadsheet shows how many scenarios the team came up with, and how many of those scenarios were explicitly stated in the requirement, and how many of them were not. And of course, during the scenario process, we encourage people to go and think about scenarios that are not explicitly stated in the requirement. Because those are the scenarios that are forgotten. Those are the scenarios that were overlooked by the person who wrote the requirement. Imagine now if your starting point is not even a requirement, but rather it is a user story. You look at the user story and say, okay, what scenarios are there? And let me tell you that 90% of your scenarios are not going to be explicitly stated in the user story. Even if when you come up with what's called implementation or verification criteria in some of the agile processes, a lot of people tell me that, yeah, we come up with those, but no, the scenarios are different. The scenarios are different. I've seen a lot of people who are practicing agile, who attend those my courses and learn about the scenarios, and they say, no, we will continue, we will also do the scenarios. We'll leave the validation criteria by itself, but we'll come and add scenarios because scenarios are more precise, they're more concrete. I can easily see if that scenario is actually in the requirement or not. Now the reason I mention about scenarios being in the requirement or not is right here. Because I can tell you that every scenario that was not explicitly stated in the requirement, guess what? That has the highest probability of failure. Because I don't know if developers have written code to handle it or not. Developers did not think about it. That's a possibility. Of course, if you're sharing your scenarios with developers, that reduces the whole thing. If your developers are aware of every single scenario you come up with, then guess what? It becomes a mute point. You can't say this scenario is likely to fail because developers did not write code for it. At the end of the day, you got a list of scenarios, you listed them, and you assisted those properties, and you came and calculated a testing priority, and the testing priority is calculated very simply. Adding up the values or the numbers and dividing by 3. If you assign 3 to high, and 1 low, and medium is 2, so 3 plus 1 plus 2, that's 6, divided by 3, it's 2.0. This is a very simple way to calculate testing priority based on these 3 factors. Now, let's be careful here. This is not talking about the priority of the scenario in terms of development. This has nothing to do with development. This is not saying that scenarios that are lower priority, we're not going to implement them. No, we have already decided during that scenario validation process that we will implement all scenarios. If a scenario were not to be implemented, then it will be removed, and will be removed for whatever reasons. And the only reasons a scenario will be removed is when someone says, well, no, that's outside the scope of this requirement. It's not going to be removed because it's not important. In my opinion, if we agree that a scenario will or could in fact happen even with the lowest frequency, then it needs to be implemented. Now the question is, are we going to test it or not? So you can sort this spreadsheet by priority. So you see all the higher priority scenarios at the top, and you say, okay, this requirement has about 50 scenarios, about 30 of those are going to be 2.0 and above. And you say, we're going to test those. However, what are we going to do with the rest? That's what I mean by sharing the testing responsibility with developers. Do not overcommit yourself. So you go back to developers and say, okay, here's what we're going to test and here's what we're not going to test. In fact, developers, please focus on those scenarios we're not going to test. And after all, we are all one team. We all care about the quality of the release. So then share the responsibility, have demand from developers to test the remaining. Of course, if developers can say, well, no, I'm not going to test that. I'm going to close this discussion by saying this. If developers are going to claim that they're doing any amount of testing, then that amount of testing must be demonstrated in the form of scenarios. So if you as a developer tell me, yeah, I tested, I did some unit testing, I'll say, which scenarios did you test? If you cannot speak about your testing effort in terms of scenarios, then you did not test. Because we're not testing anything. We don't test just anything. Okay, if you say, I tested that screen, I say, within that screen, which scenarios? All right? Now, if I know this can become a little bit of a controversial issue, please, if you have a different opinion, share it with me. Let me go quick here now to see some of the questions. I have a question here that says, if developers not doing enough unit testing and they deliver the code and we find the basic defects, okay, which happens all the time, how do we get to the point, how to get the point crossed to help a team that they need to do more unit testing? I think that question has been answered. Sharing the scenarios. As I said, I just said that. If developers are supposed to do unit testing, we share the scenarios. In fact, in my own practice, we put the scenarios out there, and a developer, before he or she can check their code into the configuration management, they have to declare which scenarios they tested under unit testing. And they have to check those scenarios. The number of scenarios tested by developer is the best indication that developers have done unit testing. Now, the question really is about how do we get the point across to convince them? Well, I don't know if we need to convince them. If I have 50 scenarios that need to be tested and I can test only 30, so we're going to have to put it on the table and say, what's going to happen to the other 20? Does a developer ever want 20 scenarios to go out in the field without being tested? Remember, we already helped in the process by coming up with those scenarios. And again, another question says, how can a person ensure code coverage with black box testing? That's interesting. In fact, we did not talk about glass box testing or white box testing here. We as testing professionals do black box testing based on what? Requirements and scenarios. So to me, the level of code coverage is ensured by the fact that, one, we have a larger number of scenarios. Two, we made sure that every scenario we came up with is taken by the development team to write the code. So if the only thing we have to make sure of is that developers are not just writing code from, you know, in a vacuum. They're not sitting in their cubicle just writing code. They're writing the code to address every single scenario we defined. And the test team is writing test cases to address every single scenario. So it goes naturally. We don't even have to work any further. In fact, I'm going to tell you this process of scenario-based development and testing makes the concept of code coverage very simple. It says, don't even get code coverage tools to measure how much of the code have you tested. Just to do this, just to make sure your developers are writing code to the scenarios, your testers are writing the test cases to the scenarios. And with that being said, you are making sure that every single block of code is being tested. Done. That's the highest level of code coverage. Of course, there is a question about code coverage tools. Yeah, there are many tools in the market that can help you measure code coverage, but they don't achieve code coverage. Let's be clear about that. Code coverage tools are supposed to tell you the level of code coverage based on your test cases and based on the code, but they don't improve code coverage. They are measuring tools, they are not. Because the question here says, can code coverage being covered by certain tools? I'm going to say no, but it can be measured by certain tools. There's a question about the handouts at the end of the presentation. We don't really send the handouts, but as Eric, the host, said earlier, all our webinars are being recorded and they are available on YouTube and on our website at iist.org or PSQTconference.com, or just to go to YouTube, go to the IIST website and follow the IIST YouTube channels. All these scenarios, all these webinars are posted there. I don't know if this is a comment or a question. Someone says 100% requirement coverage. Yeah, I mean, this is requirement coverage, not code coverage. Requirement coverage is about and again, the scenario process allows us to break the requirement into a larger number of scenarios. And as I always say, the more scenarios you can come up with, the more testing you're going to be doing, the higher the requirement coverage is going to be. There is a question about automation, the value of automation. I don't think this presentation is about automation at all. I'm sorry, the person who asked 2 questions about test automation, this is not the place for it. With that, I believe I answered all questions. Thank you so much for being with me today. I hope the webinar has been of value to you. I'll now turn the webinar to Eric.
Thank you, Dr. Hanna, for your time today, and I want to thank everyone for joining us for today's webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit www.iist.org. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day.